What I want to do today is kind of walk you through very quickly what we've been doing at StackState. We're both a customer as well as a partner of Elastic, and a lot of our customers use Elastic as part of their basically, enterprise search observability solution. But what we do at StackState is that we try and make sense of all the data. So in other words, a site reliability engineer is spending a lot of time reacting to errors, like you can see here from my Elastic environment, errors pulling metrics, something is unavailable for whatever reason. This is obviously Elastic, but usually with an application side of things, there are issues. So what we do at StackState is that we try and pull everything together into a topological view. So with Elastic, in order for us to get this view, we have a graph database that basically can sit in the back end, and it can look at, the event data set as well as the message, including being able to extrapolate IP addresses, ports, and all this kind of fun stuff. And then we turn it into a topology with relationships. And the way in which we can do that a little bit better than most is because we've built a graph database that's versioned. So in other words, we have a time travel capability, which means that if something comes into our log that maybe is an IP address that wasn't referenced for over 10 days, we can still put two and two together because we have a year's worth of component data, its relationship data, as well as its telemetry data in our topological view. Then we're also able to pull in things like telemetry data. So if I go to a pod, which is very easily noticeable within Elastic, I'm able to actually get information on the actual pods themselves. If I go into this example of a controller, I'm also able to pull things like health data from Elastic to even understand whether the thing is healthy or not. But what we do is, like I said before, Elastic is a means to an end for us, in that we're basically providing a product that automates what a site reliability engineer is doing. In other words, taking all that log data, taking all those changes, taking all that complexity that is within the environment, and basically plotting it into a database. And then because we have that ability to group these components together, look at the relationships, no matter how complex they may be, whether they're multiple, whether they're grouped, whether they're more than just a one-to-one relationship, whether there are multiple relationships, and being able to group them all together and do root cause analysis for you. And so what that means here is that with this particular issue that I've got, whereby, I've been told by Elastic that the container's not ready within my shopping carts container. I've been told that there are insufficient read replicas by Elastic again for my pod, for my replica set. And then I've been told that the pod's not ready again by Elastic, that my pod just isn't ready. But what we do is that we're also looking at the YAML files, we're looking at the changes, we're looking at the existential configuration changes that may be happening outside of the application. So in this scenario here, because we're also plotting the relationships, not just with our Kubernetes cluster and the apps, but also with Amazon, I'm then able to understand the relationships between AWS, my Kubernetes application, as well as AWS security groups, so that for this one particular issue, instead of me having to go through logs and trying to understand and consolidate everything as to what the issue is, because we can consolidate all of that data into a topology for you, I can provide you the alert storm combined into a single problem, but then also the probable causes. And so here I can see at 12:37, somebody actually ripped MongoDB, the database, away from my shopping carts service within Kubernetes. And that effectively has meant now that I'm left in limbo with absolutely no ability to actually write to the database from my shopping cart container. I wanted to kind of give everybody a lightning round view of what we're doing with Elastic Data, how we're taking that Elastic Data, converting it into a topology, putting it into telemetry, even pulling health data for individual components just from Elastic Data. Then by using things like eBPF-based discovery within our agent, we're able to then tie all of the noise and data consolidation that has been performed by Elastic, put it into context of an application, as well as then being able to hopefully provide the root cause so that you can avoid the war room. A lot of companies that are out there today and products, they're talking about reduction of mean time to resolution. Reduction of mean time to resolution, for the most part, is by alerting you of the issue as quickly as possible. We're saying, let's go to the next level and get rid of the real-time consumer, which is the war room, and present the root cause for you on a plate. So take all of your alerting data, take all of your topology data, use that as a baseline as opposed to a nice to have, and then using the changes that are happening within that topology to actually guide you to the most probable root cause, which is usually the actual root cause to your issue. If you want to get in contact with me, my name is Anthony Evans. I'm a solution consultant with StackState. I've lived through this pain myself, working in AI for years with AWS and Kubernetes. And I was just glad that we're able to bring a solution that helps not only us, but then also our customers as well, in the form of being able to add a new layer of visibility and observability on top of the Elastic data.